Around IT in 256 seconds by Tomasz Nurkiewicz. Episode 40. Docker.
When two processes run on the same machine, they are somewhat isolated. For example, they cannot read each other's memory. However, they still share the same file system, libraries, network ports, and hardware, CPU and memory. Docker allows running processes with greater isolation on a Linux machine. Processes like web servers, databases, or web applications. Traditionally, to achieve better isolation, virtual machines were used. Virtual machine is essentially an operating system stored inside of another operating system. For example, Windows running inside Linux. Typically, you run a few VMs on a single host. Unfortunately, a virtual machine has an overhead. It takes several seconds to start and uses a significant amount of memory. Docker is somewhere in between. Better isolation than plain processes, but it's not quite yet a VM. Many people claim that Docker is essentially a lightweight virtual machine. In reality, Docker runs an ordinary process, but wrapped in multiple Linux features. For example, thanks to Linux namespaces, two processes can listen on the same network port. Thanks to cgroups, Docker can put a hard limit on the amount of memory and CPU each process can get. Thanks to chroot, each process has its own file system. The last one is especially important. Imagine you have two web applications. Both need to listen on port 80, and both require the same global library. Unfortunately, in two different incompatible versions. Traditionally, this was really hard to solve, and often led to weird deployment and runtime failures. With Docker, each process has its own independent copy of the file system. Such a copy contains the exact set of libraries and tools it needs. Only the Linux kernel is shared. All of these capabilities are neatly packaged inside a so-called container. A container is really just a file system containing the operating system distribution and everything needed for a process to run. For example, Java runtime, Python libraries, Node packages. You don't have to worry about conflicts like multiple Java versions or bloated Node modules. Each application has its own copy of the entire file system. We typically run a few, maybe 10-ish virtual machines on a single host. However, it's not uncommon to run tens, if not hundreds, of containers. Just to give you a brief overview, MySQL inside Docker starts in about 1 second. The same applies to Nginx or Django. By containerizing them, we make installation less error-prone. We simply type docker run MySQL and do not worry about installing external dependencies, creating users and configuration files, permissions, network ports. It's also slightly safer because MySQL is isolated from other processes running on the same machine. Docker not only makes it easier to run any database or server locally. These days, it's a de facto standard to deploy containers rather than naked processes. Deployment via Docker is simply much more predictable. Docker itself is quite low level. Typically, your application consists of multiple containers that need to be orchestrated. There are several tools from Docker Compose to Kubernetes that can help. But that's a topic for another episode. In the meantime, thanks for listening. Bye!